Sometimes with a system of simultaneous equations, you only need to solve for one of the variables, and in that case, the method of elimination is a good choice for doing that. So the way that this works is I will use each of the equations in order to try and eliminate one of the variables. So here I'm going to start with equation number 1, and I'm going to solve for v1. So v1 is one of the variables that I would like to eliminate. I want to keep v2, but I want to get rid of v1. So looking at equation number 1, what I will get here is 4v1 is equal to 3v2 plus 36, which is v1 is 3/4 of v2 plus 36 over 4 is 9. So this is my equation for v1. I'm going to call this one, I'm going to call this equation 1a. So it contains the same information as equation 1, but I've just rearranged it. So my next step is to substitute this into the other equations. So I'm going to substitute it first into equation number 2, and then I will later substitute it into equation number 3. So in particular, what I will get when I do that is I have minus 4 times v1. Now v1 I've just solved is 3/4 v2 plus 9. And then the rest of my equation 2. So that is 5 v2 plus 14 v3 minus 120 is equal to 0. And then I can just simplify this a little bit. So I will have minus 3 v2 minus 36 plus the rest, 5v2 plus 14 v3 minus 120 equals 0. And then a little bit more simplification that I can do. So I have like terms on the v2, so that will leave me with 2 v2 plus 14 v3 and 120 combined with 36 will give me minus 156. So this one here now, I'm going to call this equation 2a. So it contains the same information as equation 2. I started from equation 2, but I've now eliminated one of my variables. I got rid of v1. So that's good. I'm kind of making some progress. I need to do the same thing with equation 3. So what I'm going to do is substitute from 1a, substitute 1a into equation 3. And so when I do that, I will end up with, so minus of v1, but v1 we've calculated to be 3/4 v2 plus 9, minus 7.5 v2 plus 7.5 v3 is equal to 0. And we can probably clean this up a little bit. So in particular, the minus 7.5 minus 3/4 is going to give me minus 8.25 times v2 plus 7.5 v3, and I will also have a minus 9 constant term there as well. So again, I will number this one. I'm going to call this one here equation 3a, because I started from equation 3. So now if I look at the system that remains, so that's this one and this one, I have now a simpler system which has just 2 unknowns and 2 equations. So I'm kind of making progress towards my goal of solving for v2. So the next thing that I will do is pick one of these, it doesn't matter which one, and solve for v3. I want to eliminate v3. So let's just choose equation 3a and solve for v3. v3 is one of the variables that I am trying to eliminate. So I will have 7.5 v3 is equal to 8.25 v2 plus 9. So v3 is, we just grab our calculator, so 8.25 divided by 7.5 is 1.1 times v2 plus, so 9 divided by 7.5 is 1.2. So this one here now, this contains the same information as equation 3. I'm going to call it 3b. So I can now take this equation 3b, substitute 3b into equation 2 is the one that I haven't used recently. So I will substitute this one into equation 2. So equation 2 told me that 2 times v2 plus 14 times v3, but v3 is this guy, 1.1 v2 plus 1.2. So continuing then from equation 2a, minus 156 is equal to 0. And at this point, I have one equation and one unknown, so now it becomes a little bit simpler. I'm nearly there. So let's just expand these brackets. So 14 times 1.1 is 15.4 v2. 14 times 1.2 is 16.8 minus 156 is equal to 0. The v2s will come together to give me 17.4 v2, and 16.8 minus 156 is going to give me 139.2. Therefore, v2 is just going to be 139.2 divided by 17.4, which is 8 volts. And so in this way, I've been able to solve for the variable that I was after. If I needed to know the other variables, then the strategy that I would follow is I take my knowledge of v2 and then I would substitute it back into one of these equations. So for instance, substitute it into 3b is going to give me the value for v3. And then in turn, if I needed to know v1, I could go and substitute back into this equation back up here. So it would just be a little bit more algebra if I needed to go and solve for all of the other values. But in this case, the question's only asking me for one of them, so I'm actually done at this point. I can stop here.